This is Algebra 2, Chapter 8, Section 6, in which we will be solving rational equations. A rational equation is just an equation that has one or more rational expressions involved. So you're looking at fractions in your equations all over the place. Now, the best way to attack this, the easiest way, is to first get rid of all your denominators. If you can get the denominators out of your way, then the rest of it becomes easier. So we have a basic game plan. Whenever there's variables in the denominator, the first thing you want to do is multiply each term by the common denominator. If you remember back in Section 2, we found common denominators when we were adding and subtracting. The same idea works here. Once you multiply by the common denominator, then you want to just simplify each of the terms. This is going to end up canceling out the denominators. They'll be gone. Now you'll have an equation that's just like stuff we've been doing. Stuff that you already know how to do. And then the last step, which is really quite the almost the most important one, is to look for answers that are invalid. Look for extraneous answers that don't fit the original problem. Alright, we'll start with the relatively easy one. We need to find a common denominator for these three denominators. Well, since 2 goes into 10, really what I need is a 10 and an x plus 3. So I'm going to multiply each one by 10 times x plus 3, and you notice I put it in red, just to show you that each term got one of those. Now it's time to do some canceling. In the first one I can cancel x plus 3. Here 2 can cancel into 10 5 times, and here 10 can cancel 10. Okay. What am I left with? I'm left with 2 times 10 is 20, 3 times 5 is 15 times x plus 3, and over here I've got 19 times x plus 3. I'm going to distribute, then I'm going to collect up terms. Over on the left I've got some numbers that I can combine together. Move the terms around so that the x's are on one side together and the y's are on the other together. And then solve, and I get x equals 2. Now when we look for extraneous solutions, we're looking to see if any of our original denominators would be equal to 0. So I'm going to put the 2 back in up here. 2 plus 3 is 5, not 0. 2's definitely not 0. 10's definitely not 0. So this one, the answer is okay. We get to keep it. Let's tangle with another one. Okay, we've got 3 rational expressions to work with. I'm going to factor my denominators to see if it will help me narrow down what I need for common denominators at the end. Okay. I see they both have an n plus 1, those two, and I need an n minus 1. 2 goes into 4, so I don't need to worry about the 2. 4 times 3 is 12, so this is my common denominator. So I'm going to put that common denominator on each term, just like I did before. I'm going to multiply it through to each thing, and then I'm going to do some canceling. So n plus 1 cancels n plus 1. 3 into 12 leaves 4. Okay. N minus 1 and n minus 1. 4 into 12 leaves 3. N plus 1 and n plus 1. 2 into 12 leaves 6. Okay. here's a good place to stop and take a look. Are all the denominators gone? Yes, they are. If anything hasn't been canceled out yet, then you need to try again with your common denominator step. So now, since the denominators are gone, I'm going to do some cleanup. 7n times 4 is 28n times n minus 1. 5 times 3 is 15 times n plus 1. 3n times 6 is 18n times n minus 1. Now I'm going to distribute. Okay. I see squares, so I want to bring everything over to one side. I'm going to bring it all to the left. There's a common 5 in each term, so I'm going to divide everything out by 5. Now it's down to something I can factor, and then I can solve each one. Subtract 1 divided by 2 gives me negative a half. Add 3 gives me 3. If I put either one of these two numbers back in over here, I don't get 0. The only problems would have been at negative 1 or 1. So these two answers are both good. Okay. We have one more of this type. We have 2 over z plus 1 minus 1 over z minus 1 equals negative 2 over z squared minus 1. I'm going to factor that denominator so that I can see if I need anything extra for the common denominator. I don't. Each term gets the common denominator tacked on. Okay, again, notice I did it in red so that you can see every term got it. Now it's time to cancel. Z plus 1 with z plus 1, z minus 1 and z minus 1. And here, both of them cancel. All the denominators are cleared out, so this is a good thing. Okay, now we're left with just cleanup work. 2 distributes. Again, here's a danger point. Negative 1 times positive 1 makes negative 1. A lot of people will make a mistake and put plus 1 right there. Collect up my terms and move the 3 over, and I get z equals 1. Let's test it and make sure we're okay. 1 plus 1 is 2. That's all right. 1 minus 1 is 0. Uh-oh. Can't divide by 0, so this answer is a bad answer. That means no solution. Now, along with solving these things, we have applications of them where we have to deal with both regular problems and with word problems. And there's different kinds of word problems, 3 of them. We're going to look at those. Our first one is the solution problem. Okay. We have a 65% fruit juice solution that we're going to add in to something that had 10%. Now, we want to know how much of the 65% we need to bring that, what used to be 10%, up to 35%. It sounds a lot more complicated than it really is. Okay. I don't know how much of the 65% I need, but I do know the basic idea. The percentage of the juice times how many milliliters I used for the 65% kind, plus what's being mixed in with it, the 10% kind, equals the total amount over here. Okay. Well, let's fill in what we know. We know this one is 65%. Usually you would make this 0.65, but then you're just carrying decimals around. And you don't really want to do that if you don't have to. And since everything is a percent, we can get away with it. We don't know how many milliliters, so 65x, 10% times 15 would make 35%. Now here's the tricky part. I had a jug that had 15 milliliters. I had a cup that had 15 milliliters. And I add X milliliters to it. That means I have X plus 15 total. Well, let's clean up, including distributing over here. Move things around. And what I would need is 12.5 milliliters of this 65% juice to make it go from 10% up to 35. Okay. There are two other types of word problems, but I'm running up against the clock a little bit. So we will continue this lesson in part 2 of the video. Make sure you watch the second part as well as the first. And of course, if you haven't watched the first, you're not hearing me say this to you. But make sure you watch the second part to see the rest of how these word problems work. So until then, we will temporarily adjourn, and we will see you in part 2.